When you open infiniSee, the first thing to do is to define your query. To do so, you can either take your favorite drawing tool like Marvin, ChemDraw, whatever, and draw your molecule and copy it as a smiles and paste it in here. You can drag and drop it there, or you can load it from a file using the load button here on the toolbar. I click on this, load biotin as SD file. You see here allowed as SD, mol, mol2, smiles, and PDB. I load the molecule and it appears here in my query window. The second thing to do is to load the chemical space or library you want to search in. To do so, you click on the settings button and you can either download it. You will be prompted to our website to download ready available spaces like the knowledge space or the real space. Equally, you can load your own spaces like I will do here with the pre-downloaded knowledge space and the real space. Equally, you can load a library, for example the eMolecules free library here as a smiles file. Now I have different options where I can search them in. To search, I select the one I want to search, like here the knowledge space in version 2.5, and I say apply and close. If you forgot later on, down here is shown as well which space will be searched in. Next thing to do is to adjust the search parameters. I click on the button here on top on the toolbar. I can select the number of results I want to obtain. I can set the target similarity of the hits I want to find. I can make them very similar to my query, can make them slightly dissimilar, or I can go down and get maybe good scaffold hops or more surprising molecules. So I leave it here on the top. Equally, you can set a minimum similarity if you want to deny everything that's too unsimilar. You can set this a little bit up. The total diversity allows you to cluster your molecule. If you put this down, then the results will be different from each other, but this is slowing down the computation time a lot. This is why it's grayed out when you go above 500 solutions. Last thing to do, click the search button and your search starts. To make this video not too long, I will cut it here and record back in the moment where the search is ready. The search time mainly depends on two parameters. One is the size of your query. The bigger it is, the longer is the searching time. The second parameter is the size of the space, of course, as well. The bigger this one is, the longer is your searching time. I here have 4 CPUs and it took now about 4 minutes to search for biotin. In the space, the knowledge space has about 10 to the power of 15 molecules in there. Okay, now I obtained my results and I'm quite happy that the biotin head group was retained. To find out a bit more about those molecules, I click on them and then here on the lower left side the matching images occur and I can select different molecules or deselect. If I want to select or deselect all, I can do this here on top of the table and just go and select the ones that I like and want to have a look to later on. If for any reason you don't like your results, then you can define parts of your query molecule that are more interesting for you. Example, let's say here the cyclic urea is very important, then I click on it and now the green highlighted part shows me that node of the feature tree, and here comes up a little label and I can set the feature similarity from low, when I know this is an unimportant part of the molecule, to really, really high, to retain that bit of the molecule. Equally, what you can do is change the space you're searching in. Let's say you want to obtain molecules that you can purchase. I can take the real space now. I say apply and close. You see here down on the bottom line that I'm searching in the real space now. I adjust as well the parameters a little bit different and run the search again. Again, I will crop the video here to make it easier to be watched later on. So here are my results. Pretty happy to have found back the molecule. You see it as well here in the matching images, everything matches, and you see the local similarities for all those parts of the molecule. They're all one, means like this is absolutely the same molecule. Again, I uncheck everything to select those molecules I personally like a lot. And the last thing to do would be to export those molecules, which you can do here on the export checked search results button. Before I do this, I go back to my settings and set some export settings. I want to mask not my query here. I'm not interested in hiding the biotin, but if you have a compound which is sensitive regarding the IP, you can mask it here. Using that switch, equally you can tell the computer to generate coordinates before the export. I leave it like this and save the molecules to my hits.sdf so I can do a post-processing and every other tool I'd like to.